Imagine looking deep into space, not just thousands or millions, but over 13 billion light years away. What would you expect to find? Darkness? Chaos? A young, empty universe? Instead, astronomers have just found something astonishing. Oxygen. Yes, oxygen. In a galaxy that formed only 300 million years after the Big Bang. Let's break that down. This isn't just a scientific headline. This changes everything we thought we knew about the early universe, and here's why. We call this galaxy Jades GS-Z14-0. It's not a catchy name, but it just became one of the most important objects in the sky. Thanks to the James Webb Space Telescope, astronomers were able to detect clear signs of oxygen in its light. Now, why is that such a big deal? Oxygen is a heavy element. It doesn't just float around after the Big Bang. In fact, the early universe, right after the explosion, had only hydrogen, helium, and a trace of lithium. To get oxygen, you need stars, big hot stars that live fast and die young in violent explosions called supernovae. So if we're seeing oxygen at this distance, it means stars had already formed, lived, and died, and even enriched their galaxy within just 300 million years of the Big Bang. That's fast. Much faster than we thought was possible. This tells us something profound. The first galaxies didn't evolve slowly and quietly. They were turbulent, active, and chemically complex, far earlier than our models predicted. Let's pause here. Imagine you're trying to understand how cities evolve, and someone shows you an ancient town from 500 years ago, already with skyscrapers, internet, and neon lights. That's what this discovery feels like. A civilization too advanced for its time, but in this case, it's not people, it's matter itself, the building blocks of life, forming earlier than we ever imagined. The oxygen found in Jades GS-14-0 came from starlight, more precisely from the spectrum of light captured by the James Webb Telescope. Each element leaves a signature, a specific wavelength, like a barcode, and oxygen has one of the clearest, most recognizable signatures in the universe. So we're not guessing. We saw it directly. This isn't just about one galaxy, it's about what it means for all early galaxies. If oxygen is already common this early, then the universe matured faster than we thought. And maybe life could have started earlier too. Because remember, oxygen isn't just a random gas. It's one of the most essential elements for complex life as we know it. It's in your lungs, in water, in every cell. No oxygen, no life. So when we find it 13 billion light years away, we have to ask, what else was already forming back then? What seeds were already planted for future stars, planets, and maybe civilizations? And there's another twist. The galaxy where oxygen was found is surprisingly bright, meaning it's massive. And here's the problem. In theory, galaxies that big shouldn't exist so soon after the Big Bang. It's like seeing a fully grown adult just moments after birth. This suggests that our current models of galaxy formation might be wrong. Maybe gravity pulled matter together faster, maybe stars formed in huge bursts, or maybe there's something we've missed entirely in the physics of the early universe. This is why this oxygen discovery is not just an astronomy update, it's a scientific earthquake. Of course, the James Webb Space Telescope is only getting started. Its instruments are so sensitive, they can see not only galaxies, but the chemical fingerprints inside them. We're now entering an era where we can watch the universe grow up in real time by looking far into the past. The further we look, the more surprises we find. What we once thought of as a dark, empty baby universe was actually lighting up, forming elements, and possibly preparing the stage for life, all in the first 2% of cosmic time. So what's next? Scientists will now begin searching other ultra-distant galaxies for similar signs. If oxygen turns out to be common out there, it could mean that the universe was more life-friendly from the very beginning than we ever imagined. And if that's true, then the question isn't just how early did stars form? The real question becomes, how early could life have started? We may never know for sure, but every time we look deeper, the universe whispers back, I'm older, richer, and more alive than you think. This isn't just about oxygen in a distant galaxy. It's about rewriting the timeline of everything, from stars to galaxies to the potential of life itself.